So this is going to be a lesson about the trigonometric graphs. In this lesson, we're going to learn to actually graph the basic trigonometric functions. Remember that the trigonometric functions take an angle in as the input and return either an x or a y coordinate. Now to begin with, we're going to focus our attention on the sine of theta. To really visualize this, I want you to imagine that we had a light pointing directly at our point. As we can see, we get a shadow centered around this point. The point that this shadow makes on the y-coordinate is called the projection of our point onto the y-coordinate. Now we'll get rid of the torch, and then we'll imagine how the position of this shadow changes as we move our coordinate around the circle. Now to actually visualize this function properly, we're going to need to use another axis. Now I'll raise the point just a tiny bit so it's exactly at 1/8 of a revolution. We'll also fill in the y-coordinate when the angle is 0 as well. Now I'll move through every 1/8 of a revolution and plot its corresponding y value. If we go ahead and join all of these points with a smooth line, we will have the graph of the sine of theta. Now we could go ahead and repeat this whole process for the cosine of theta, but to do this we're going to have to draw the graph slightly differently. This time it's going to be really hard to draw this all on without a guide, so I'm going to draw on some guides to help us actually draw these functions properly. Now in this initial case when the angle is 0, you can see that the x-coordinate is exactly equal to 1, so we can go ahead and graph that on. Now when we rotate by 1/8 of a revolution, we end up over here. Now once again, I'm going to methodically go through every 1/8 of a revolution to get an approximate graph of the cosine of theta as well. Now if we again go ahead and connect these points with a smooth curve, this curve will be the graph of the cosine of theta. Now whilst I've drawn these graphs in revolutions, there's really nothing stopping me from drawing them in radians, or if I wanted to, I could even write this all out in degrees as well. The units you're using should be clear from the axis labels you've written out, but it's nice to write it out explicitly just in case. Now from this page we know how to graph the cosine of theta and the sine of theta, but you'll recall that there's another trigonometric function that we need to know how to graph, and that's the tan of theta, which I'll go ahead and draw on a new page. Let's bring down the graph from the previous page first. Let's draw on the point at an angle of 0. Now you can very clearly see that when we have an angle of 0, the gradient is exactly 0, so we can go ahead and draw this on the graph straight away. Now if we move to 1/8 of a revolution, I want you to remember that we can visualize the gradient like this. Remember that the height from here to here is a nice visual for the gradients, and that means we can easily show this height on the graph. Now this time I'm going to increase the angle a little more, but not by a full 1/8 of a revolution. Now this time, if we actually go ahead and set the angle to 1/4 of a revolution, we'll notice that something a little bit strange is going to happen. Now since the angle is completely vertical, it turns out that it's actually never going to hit this line, because these two lines are actually parallel to each other. Therefore, at 1/4 of a revolution, the tan of theta is actually undefined. Now just to verify this, let's go ahead and try typing this into our calculators. Remember that 1/4 of a revolution is the same thing as half of a semicircle, and therefore our angle is just pi on 2. So when we try putting tan pi on 2 into our calculator, we notice that it gives us an error, and that means it just has no value there. Because the tan of 1/4 of a revolution is not defined, we're going to say that this point represents a vertical asymptote. Now as soon as we pass this point, you're going to notice that the gradients become negative, and that means the projection is going to come back from the negative side. Now we can continue this for the rest of the angles. Note that there's also going to be an asymptote at 3/4 revolutions as well. Now again, we can join these points with a smooth curve to get the graph of the tan of theta. Now there's only one tiny thing left to say, and to say it, I'm going to bring back the graphs of sine and cosine, just for a moment. Now for sine and cosine, you can put in any angle you like, so the domain includes every possible angle. Now for tan, you can also put in any angle you like, except for odd multiples of 1/4 revolutions. Now this one looks a little bit scary, so let's just read it in English. The domain of tan includes all the numbers from -infinity to infinity, except for any odd multiples of 1/4. Now if we think of the ranges of these functions, you'll notice that both cosine and sine never pass 1 or -1. This is because they both get defined on the unit circle. Now, I'll read this one in English too. The range of cosine includes every number from -1 to 1. Finally, when we look at tan, you notice that it could be pretty much any number you like, and therefore the range of tan includes all real numbers. And with this, we've completed our discussion on the trigonometric graphs.